Hi, my name is Susan Mundari, and these are my team members, Caleb, Justin, Keith, and Luke. And for this semester, we developed a device called TempCheq based on our prototype from last semester. TempCheq is a device that monitors temperature, movement, as well as location of pet animals to which it is mounted on, and it transmits those data to TempCheq app through Bluetooth BLE 5.0. It also has a IP67 compliant as well as rugged enclosure to withstand normal wear and tear. The main purpose of this device is to monitor recovery of post-surgical animals, but it can also be used for monitoring temperature for daily life.
So last semester we had a working prototype soldered onto a proto board, but our goal this semester was to create a market-ready product. So I want to stress that this is not just some temperature monitoring device. This is a product. It is functioning as a working product. So in order to do that, we designed our own custom PCB. It incorporates all the components needed for the device to operate, and then we have a separate board that has the temperature sensor on it, which will be thermal pasted to a aluminum area on our enclosure, which leads me to the enclosure, which we also custom designed and had machined out of polycarbonate. So it is very rugged. It is also IP67 compliant, which includes waterproof up to 3 feet. And I'll pass it off to my team member.
And for this semester, we have made some changes to the hardware for the device. We have changed the microcontroller unit into a different one, which provides us a longer range of Bluetooth. This also comes with the USB serial bridge, and it's also cheaper. We also changed from the thermistor into the TMP117. It's a digital temperature sensor that's easier to calibrate. It's more accurate, and it's come with the alert interval for when the temperature reaches configurable threshold.
And along with hardware changes, we also had some software changes. So last semester we had it transmitting data via polling, which means it will just constantly send data. But for this semester, we wanted to implement interrupts so that we could save battery life. And so we were able to implement that and be able to conserve battery life. And also we want, not all data is necessarily useful data. So measuring temperature on animals, we wanted only to alert us when the temperature was within a bad range, like you could tell like the animal was like not recovering well or something like that. So that's what we have implemented.
As for practical applications, right now our main target is on horses, cats, and dogs. But I guess we'll move on to questions.
Any questions?
How does that attach to the animal to pick up the temperature?
So that wasn't in the scope of our project. However, our sponsor has told us that it's going to fit inside of a sleeve that will be wrapped around a leg, or in a horse's case, it would be wrapped around the tail. Yeah.
How large is it? Do you have one? Or?
It's about 2 inches by 1 inch.
What device would it be transmitting to in a home environment? Because you said that it was for smaller animals.
Yes. So it transmits via Bluetooth to a phone. So we also have an accompanying mobile app that a CS team worked on. So all the information will be sent to that, and you'll be able to view everything from there.
Okay. You mentioned that you had concerns about power, but I don't see any goals here for what the power should have been.
Yes.
And what the lifespan of the battery should be.
So really the main purpose of this is for monitoring animals after surgery. So we really want it to work especially overnight. So it at least to meet overnight. However, we incorporated a low power system, and we were able to get the battery life up to about 48 hours.
Yeah, related to that, are you talking about polling? Are you talking about telemetry and the on-demand versus like continuously streaming the data? What is the interrupt?
So I'd like to answer that. So we have two different mode of transmission. One is event-driven interrupt. So let's say when the temperature goes above the normal range, then the device will start sending continuous data. But when the range is normal, we are using timer interrupt, in which case the user can configure in how many times span you want the data. So you can save 1 minute, 5 minutes, 10 minutes.
Thanks.
All right, let's thank.